notes wherever you are taking notes. Oop. So part C for the background knowledge chapter is number systems and set notation. And what I've noticed that you guys are pretty familiar with number systems, but not so sure about set notation. So the set notation stuff might not be exactly background knowledge. It might be a little bit new to you, and I'm going to zoom in on it in a second, so if you can't see it, you'll be able to. So kind of stick with me here. Remember to draw yourself a little stat box at the top of your notes, wherever that is. And there we go, it's zoomed in. So part C is number systems and set notation. I can say that backwards. And when we get into that set notation, I'm going to go over a couple of examples, and then really your best bet is to just do the work and ask for help. It's kind of one of those things you have to get some practice in to feel better with, so we're not going to do a whole lot of examples with it. We're first going to review those number systems. So most of these you guys should already know. Remember that double barred R represents the set of all real numbers. So all real numbers, it includes everything that's up here. But all real numbers is going to have integers, it's going to have decimals, it's going to have fractions. If I were to draw this on a number line, you know that's 0. Let's just say we've got negative 10 and 10. All real numbers is going to keep going both directions. It's everything, all those little decimals in between. The double barred N, or that bolded N, represents the set of all natural numbers. Natural numbers, they're like those counting numbers. Those numbers that you first learn when you're young. So those numbers, we've got 0, 1, 2, 3, and so on. Z represents the set of all integers. So remember, integers can be positive or negative. And so I've got positive or negative 1, positive or negative 2, and so on. And sometimes you see it where you've got it on both sides and like dots on both sides. You might have seen it that way. I'm going to represent this one on a number line too, because it's just a little bit different than the other number line we've got. So because those integers don't include like 0.5s and the 0.75s, if I were to represent this on the number line, I would just have to use these dots. So it's a little bit weird. It's a little bit different than what you're probably used to. But to represent that, then I've got these dots because I know I'm using 1 and 2, but I'm not using like 1.5. I'm not using anything that's in the middle here, just those integers. And it is assumed that it's going to keep going in either direction because I've got dots across that whole piece there. Are we okay so far? So then we've got the set of all positive integers, which the notation is that a z plus, so just positive integers. Positive integers is very, very, very similar to the set of natural numbers. There's just one thing that's different. We don't have 0, because 0 is not positive, it's not negative either, but that's the only thing that's different between your natural numbers and your positive integers. And then the last number set that we're going to talk about is represented by that letter Q, and that's used to represent the set of all rational numbers. So remember, rational numbers are either decimals that terminate, like 1.5 stops, or that repeats, like 1/3. You know, if we punch that in a calculator, do 1 divided by 3, it's going to be 0.33333. So to represent that, remember, a rational number can be written as a fraction, so P over Q, but P and Q have to be integers. And we know Q cannot be 0, so we know you can't divide by 0. So you guys have seen all these letters before, right? Maybe? Maybe not. If not, that's okay. Hey, welcome to these letters. So you'll get used to it. It doesn't necessarily come up every day, but it's something that you should know. Working in mathematics, the R for all real numbers. We're going to see R and C the most, and C for integers. And just keep in mind that integers are not any of those decimals. Positive or negative is not good, but no decimals with that. We're going to get into that set notation, which you might not have seen before, so don't freak out about it. Questions on this stuff so far? Are we still going? Am I going too fast? Am I going to do a race? Alright. Okay, a little bit bigger. So this is our set notation. So we're going to practice writing some in a little bit here and looking at that. Now, I've got that funky little parenthesis. We'll have an X, this little vertical line. I'm going to tell you how to read it in a second. And then some kind of description of what's going on using symbols here. Now, we've got a verbal description of it right here, but there are different ways to explain them verbally. So when you try your assignment, if what you write down is a little bit different than what's on the back, check with me. You might be just fine. So this is the set of all values that x can be such that x lies between -3 and 2. There are other ways to say that. You could also explain it x such that x is greater than -3 and x is less than 2. That would be another way to explain it in words that's a little bit different from what we took out of the book here. So keep in mind there's other ways to explain it. You might not have exactly what's in the back. It does not mean that you are wrong. One important thing is this little last sentence here. Unless stated otherwise, we assume that x is real. So it doesn't say that x is an integer. It couldn't be a natural number because we got negatives. But it doesn't say anything about that. So we're going to assume that x is real. And let's just practice drawing this on a number line, okay? So if I've got my number line, does anyone remember back from algebra, if I just have a less than on my number line, am I going to use an open circle or a closed circle? If it's not equal to, and it's okay, I'm going to remind you if you don't remember, it's okay. So when we don't have the equal to symbol, we have to actually use an open circle, so I'll have to use open circles right here. And then since I'm talking about real numbers, it's everything that's in between. So 0 is part of the set, 0.5 is part of the set, -1.5 is part of the set, all these numbers in between. 3 is not actually part of it because it's got that open circle. So you can write yourself a reminder that if you've got less than or greater than, you're going to use an open circle. And if you've got less than or equal to, greater than or equal to, then you're going to have to fill that in with a closed circle. Because that's included. So it's kind of that visual representation. -3 is not part of my set. -2.9 is, but -3 is not. So kind of bringing that back from a while ago. So we're gonna do 2 examples with writing the set notation, and then you'll have some time to kind of work it through yourself on your assignment. Let me know what you're not sure on. You're gonna have plenty of time to get that done. Okay? Alright, so what we're going to do is I've got 2 different number lines that we're going to look at, and then we're going to write that set in set notation. So we're going to write it with the crazy parenthesis, and we're going to write that set in set notation. So here's our first one. So taking a look at this, I noticed something right away is that I've got those dots. So remember, those dots mean that I've got integers. That's a bad Z, I'm going to redo that. So I've got integers because I've got those dots, and I'm not using those numbers in between. It's not an all real number situation because of these dots here. Now this one, they're all positive, so technically this one could be natural numbers too. They're all positive, but either way. So when we start, we're going to start with that funky parenthesis. You know, you'll see when you check your answers that sometimes people will mix it up with like Y or N, but we're going to stick with X. We're going to write X, then we're going to write a little vertical line. So this is the set of all X such that, now when we take a look at this, I'm starting at 1 and I'm ending at 4. So I'm going between 1 and 4, but those are included. I'm actually at 1, at 2, at 3, at 4, so I'm going to make sure that I use that equal sign piece in between there. Now I do know that sometimes people get a little iffy with that compound inequality, so if you wanted to write something like x is greater than 1 and x is less than or equal to 4, those mean the same thing. So I'm going to use that compound one so we get used to seeing that because we're going to see that more often, but this means the same thing. The only other thing we have to add here is that we have to make sure that whoever's looking at this knows that it's an integer or a natural number, so we have to just say that x is in that set of integers. So this is kind of like a weird looking E that just means it's included. Now I know this is funky, I know you probably haven't done that before. We're going to do one more different kind of example, and then you'll have your assignment to practice on your own, and then ask me questions. We ready for the next one? So here I've got that number line, and I've got like this line across the whole thing. So that means I've got real numbers here. It's not just rational numbers too, because we could have some irrational things going on in between there as well. So all real numbers from -3 and almost to 4. Zoomed it in a little bit there. So we'll start again with that funky parenthesis, x, and then a little vertical line. So instead of x, such that. And it looks like we're close to being between 3 and 4. But I noticed that 3 is included, so I'm going to have to make sure I use that equal sign part so that I know that 3 is part of it. It's filled in, it's included. 4 is not, so I go up to like 3.99 or 99 and so on. Whoops. Don't write that equal to sign. Because that 4 has got that open circle, so it's not included. Now, if you remember, we said that if you don't see a certain set, we assume it's in real numbers. So you could finish this one right here, because we would assume it's in real numbers. If you want to, I'm going to just do it in a different color. You could add that it's in real numbers. That would not be wrong. But I know when you check your answer in the back, they kind of leave that off because we're assuming, oh, it doesn't say, so it's real numbers. But putting it there is not wrong. So, questions so far? Now the stat box, I kind of let second hour do their own thing, but after working with second hour, I came up with maybe some things that I noticed. So I just said that you're expected to know and use this moving forward in this box. Write one tip for yourself. Here's some tips that I've come up with, helping second hour kind of move through this. Remember that if you've got, like, let's say a line like this, we know that's going to be in all real numbers. And something that you might not remember is this is kind of like an and inequality. So that's when you're going to use, something like this with your numbers on either side. Or you can have two different things here. And I know I don't have numbers in this because I'm just making that up. But you also might see stuff like this on like the same number line. It's still all real numbers, but it's like an or inequality. So that's stuff that you guys should know from algebra, but it's a tip to remind yourself that. So that's like an or inequality, so we're going to have like x is less than or x is greater than. So those are just the tips that I noticed. If people kind of forgot about some of that stuff from way back when. And then remember, if you've got a bunch of dots, it's going to be an integer. Every now and then it could possibly be natural numbers, so if you only want to remember one thing, integer is where it's at for those ones. Alright, so today's Thursday. So tomorrow you guys can come in with any questions on this number system stuff, and then this one will actually be due on Tuesday because we don't have class on Monday for Labor Day, right? And then the surds and radicals one is due tomorrow. But you can also check that stuff in with me early. So we've got a bunch of work time right now, so I might check in with you guys later to see if you're done or whatever. And we get done at 10:11. We have to relearn all these times, right? I don't know any of them, so I'm going to try and say them out loud to you guys so that I remember them as well. So we get done at 10:11. Oh, and it's just the worksheet.